Hello guys, welcome back. So like I promised you, we will see a lot of cases in the upcoming videos about the partial fractions. So today we will talk about the first case, whereas denominator containing non-repeating linear factors and how we solve it. So let's get straight into it. So the first example that I want to discuss is a simple one. Minus 1 over x minus 1 times x minus 2. I'll give you a couple of seconds to think of how you are going to break this. Okay, so the first thing is first. We directly split the denominator containing factors into two, and we write a and b as this is. And you guys might wonder why a and b. That is because we always have to be mindful that since the power of x in the denominator, if the power of x is 1, we always have to put something which has a power less than 8. So in this case we are writing an a because like you can write it as ax not 2, but then it doesn't make sense, so we simply write it as a. So always be mindful that we always have to write on numerator a power less than the denominator. So basically here x has a power 1, and in this x has power 0. So we write it as this is, and then we work out the sum. It's simple like this. So we take x minus 1 and x minus 2 as common. So when you do that, you get this. So when you solve this, you can solve this by two ways, either by equating coefficients or by substituting values to x. So in this case I will use the method substitution for the values for x, so we can find a and b easily. So when you substitute x equals 2, you get b as 1, and when you substitute x equals 1, you get a as minus 1. So you have the partial fractions as minus 1 over x minus 1 plus 1 over x minus 2. So this is the simplest of one sums you could get. So let's try another example. X minus 1 over x plus 1 x minus 2. In these two we will break the denominator as x plus 1. We write the factors separately. Here to a and b, like I told you, the same thing applies. So when you take x plus 1 and x minus 2 as the common denominator, you get this expression. So here too, if you put x equals 2, you get b as 1 over 3, and when you put x equals minus 1, you get a as 2 over 3. So you get the partial fractions as 2 over 3 x plus 1 plus 1 over 3 x minus 2. It's simple as that. So let's try another example. 3x over x plus 1 x minus 2. Like I always told you, you write the denominating factors separately like this. Here too you write a and b, You know the reason why. So when you take x plus 1 and x minus 2 as the common denominator, you get these. So when you substitute x equals 2, you get b as minus 6, and when you substitute x equals minus 1, you get when you put x equals, so right here you have to have another factor, let's say x minus 3, otherwise it would be the same problem. So here you will have plus c over x minus 3 c over x minus 3. Oh, just excuse me for a while, there's a mistake. Okay, you get b over x minus 2 plus c over x minus 3. So when you put x equals 2, you get b equals minus 6, and x equals minus 1, you get a equals 3 by 2. And when you put x equals minus 2, it's yes. By 2. So the solving is pretty much easy. You can substitute and get the values, and then finally you will have a partial fraction and like 3 over 2. You will have a partial fraction like 3 over 2 times x minus 1 minus 6 over x minus 2 is 9 by 2 times x minus 3. Right, so that's it guys, and I'll give you 2 more examples for you to try, and you have the answer in the link. Try these examples. Try these examples, and the answer is given in the below link. You can click it and see whether you have got it right. So that's it guys. Hope to see you with another case in the upcoming video. Thank you.